Hello, let's talk optimization. Let's give optimization a shot. And let's say that we were asked, in fact, this question was posed to me recently, don't know where it came from, but the idea was, what if we were trying to find the maximum volume, which tells you optimization. Maximum volume of a rectangular prism. Okay, so let's make a, well, that's really bad, but you know what I'm going at here. I'll make two parallelograms, something like this. And let's say the surface area of this was a number like, say, like 1,200 cubic inches or square inches. Can we find the maximum volume? Problem with that one is no. If it's a rectangular prism and we have length, width, and height, okay, volume equals L times W times H. We can find the surface area of this, and let's say this thing is open-ended. Surface area, you're going to have, LW here, and then you're going to have 2L plus 2W, that times H. You still got L's, W's, and H's, and you got two equations with three variables kind of going on there, so that's not really enough. But it got me thinking, what if the base, and we'll call this open-ended, but let's say the base was a square. Instead of length and width, let's say it's side squared, and then times height. Let's say we knew that, and let's say we know the volume of this is side squared times height. And let's say we're given that the surface area is 1,200 inches, okay? So we're given surface area. Now surface area is a little easier to find in this one because instead of length and width, we just have side squared. Remember, the surface area of an open-ended one, you've got one base and you've got four sides. So with all prisms, if you want to find the surface area of the sides, it's really the perimeter of the base times the height. The perimeter of the base here is S plus S plus S plus S. It's 4S. So the surface area in this one would be the area of the base plus, for all the sides, it's the perimeter of the base times the height. So you've got these, and let's say they told you 1,200. Now this is something we can deal with. This is the sort of problem where, again, we're going to try to find maximum volume. So we're going to take this equation, we're going to take the derivative of it, provided that we can rewrite H in terms of S. If we can rewrite this equation so that the only variable on the right side is S, then we got something. And lo and behold, we can, because of this information. Just take this and solve for H. It's going to take you a couple steps. We'll subtract S squared from both sides, so we have 4SH equals 1,200 minus S squared, and now we'll divide both sides by 4S. And I can't really even clean that up yet. I guess I'll just leave it like that. That stuff goes away. H equals 1,200 minus S squared divided by 4S. Now with that, we can plug it in here. So let me rewrite my V. It's going to be S squared times this value for H. 1,200 minus S squared over 4S. At first this looks really gross if we're going to try to find the derivative of it, but it's actually not that bad because we can simplify first. I mean, the only simplification I'm really going to do that's really important to me is getting rid of an S up here and an S down there. That we can do. Cross out this S and I get rid of the squared S, so it just becomes a single S. Okay? Now I think I can rewrite this so I can use it in power form. If you look at this 1,200 minus S squared over 4, I can rewrite each of those being divided by 4. So 1,200 divided by 4 is 300. A negative S squared divided by 4, I can just make that 1/4 S squared. And now I can rewrite this by distributing as 300S minus 1/4 S cubed. That is the equation right there that I'm going to take the derivative of. For optimization, we want to take an equation, it's usually a basic equation idea. You want to get a single variable on the right-hand side. So they'll give you some extra information. If this problem said it's a cube, it would have been really easy. Just S cubed, and then we go on. Okay, but in this case, they gave you this sort of thing. So that thing I said about the cube, I'm not so sure about that. But you'll never get that anyway. So let's say we have V equals 300S minus 1/4 X cubed. Okay, let's take the derivative. I know you used to say V prime. We really should say dV over ds. It's what we do in implicit anyway, although we're not doing implicit per se here because we have a function. We have v by itself here, and we have just s on the right. So now for optimization, that's what's nicer about this compared to related rates. Now this will be 300. This 1/4 times 3 is 3/4. This drops a degree to s squared. Okay. And now we can set this equal to 0. Hopefully you see this isn't too hard to solve. I can move this over to the right-hand side. 300 equals 3/4 x squared. I'm going to multiply both sides by 4/3 because that's the reciprocal of 3/4. So those will cancel out. And this, let's see, that'd become 100. So 400 equals s squared. I believe, using my spidey sense, you get plus or minus 20. And I don't think there's any way it's going to be a negative. Can't have a negative side length. So in this case, s is 20. Now that's what we got as a critical point here. Okay, remember we took the first derivative, we set equal to 0, and we solved. So what you want to see in optimization problems is a little bit, am I not showing you all this? Let me bring it down here. Sorry about that. I'm not going back. I've been recording too long here. Okay, but this is the extra work I did, and I got s equals a positive 20. We're going to want to do a little more than that. We're going to want to do a derivative test. The derivative of the volume with respect to the side length will do this. Okay? Now some teachers want to see the minimum possible side length and the maximum possible side length. They haven't really figured out exactly what that could be. I think it's probably not that important. But one thing I will tell you is when you do a test point, don't do 0 because you can't have a side of 0. I know I got to do 20 though. This is a critical point. What we're hoping for here, okay, because we want maximum volume. I'm hoping that we go from increasing to decreasing. I'm hoping for this, increasing to decreasing, because then it'll be a maximum. It makes sense to me that that's actually what's going to happen, especially because if you look at this, it's s squared. It's got a negative leading coefficient, so a negative parabola typically goes down like that. But we should test it anyway, okay? So we should test, say, I don't know, I guess 10 and 30, okay? So we just plug that in here. We plug in 10 here, and let's see. It'd be 100, 300 over 4 is 75. 300 minus 75 is 225. That's a positive number, so it's increasing in terms of V. And then if you try, say, 30, 30 times 30 is 900. It's kind of gross, but I can tell you this whole thing is greater than 300, so we are going to get a negative, and it is going to be decreasing here. Okay? Remember, the sign chart or the sign test, whatever you want to call it, is important, but it's not as important as making a statement. You want to say here that side, in this case, well, I'm not going to say that. I'm just going to say 20 is the relative maximum because, and let's see, I guess I'll use this, because the derivative of the volume with respect to the side changes from positive to negative. I think it's okay to do any G period, POS period, REL period. If your teacher doesn't, don't do that, okay? And don't stop here. The answer is not side equals 20. Remember, we're asked what's the maximum volume. So volume equals s squared times h, or actually, we really should use this one, shouldn't we? Because this is the one that just gives us the volume in terms of strictly the side. So let me change this. 300s minus 1/4 s cubed. And now I can plug in my value of 20. Plug it in there, plug it in there. Go to your calculator. I'm going to do let's clear that. I'm going to do 300 times 20 minus 1/4 is 0.25 times 20 cubed. I got 4,000. That's what I got. 4,000, and then I forget I think I'll say inches. 4,000 inches cubed. I forget what the unit was, but I want to go to that. So there we go, 4,000 inches cubed. Wanted to go over optimization with you. Okay, and there was one more thing for a student in particular that I wanted to throw out there that I did not get the chance to tell him at our last meeting. Okay, when you talk about related rates, I know I'm switching from optimization to related rates. Okay, Sagar, I'm talking to you here, by the way. Okay, so if nothing should come back to me, it should all go to you. Let's say you're given a problem that deals with a rectangular prism. Okay, I'm trying to make some three-dimensional thing here. Okay, and it's talking about like something pouring out there at a certain rate, and that would be dV over dt. And then they ask for like height over something. Remember, on related rates problems, there's always a little bit of extra work. So on a related rates problem like this, they might tell you that the thing is, say, 10 feet wide or 10 inches wide, and maybe they tell you the height is 6. And then if they're talking in terms of the volume of the water, you can see it's kind of pouring right here. And if you're wondering, well, how does this relate to this? Okay, that's where you come up with a ratio. So on this one, maybe we say the width over the height equals 10 over 6. That was given as part of the structure of the triangular prism. And the reason I'm giving that to you is with the equation that they would give you, you might have to get rid of a W or an H. And now you could use this ratio. You could cross multiply 6W equals 10H, and then you could solve for H. Or you could solve for W and plug it in. Okay, so that's the idea. On a rectangular prism, that's important, that ratio. On a cone, a conic section, it's important. They do these a little bit differently though, okay? If it's a cone, you're probably looking at the R value here and the H value here. So let's say they told you the diameter is 10. Well, then the radius is 5. And if the height is 6, then you can see R over H equals 5 over 6. And then you can go from there, okay? Important stuff, Sagar, that's going out to you. I hope this helped you. Good luck tomorrow. Good luck.